So in this video, we're gonna find, well, we're gonna basically find the value of a resistance R so that this transfer of power between 2 points, which we're gonna call A and B, is gonna be maximum. And we're gonna find the power, which is gonna call P. We're gonna find the energy, which we're gonna call W, transfer from the system to the load in 24 hours. And we're also going to see how the system works in such a working condition. So, quite a few things to find out and see. So let's crack on. Our circuit this time is going to be given by a voltage source, a resistance, another resistance here. Then we're going to have 2 points A and B, and another resistance here, and then a diode polarizing this way, so you're only going to let the current flow in this direction. And yes, and then down here we're going to have another resistance going all the way down here. So this one is going to be my R1, this is going to be my R2, R3, R, and these are my points A and B. So the problem is saying that for the circuit on the left, we know that V is equal to 12 volt, Ri is equal to I ohm, so 1 ohm, 2 ohm, 3 ohm, and who knows. Now, it's asking us to find the value of R, which is why I said who knows, so that the power transfer at AB is maximum. Then find the power P and the energy W transferred from the system to the load in 24 hours, and how the system performs on such a working condition. So plenty of things this time, but there is nothing scary. So first of all, our action plan is to draw the equivalent circuit of Thevenin at AB. So the equivalent circuit of Thevenin at AB. So at AB, well, the equivalent circuit of Thevenin basically says that each and every circuit can be represented and simplified by just drawing a voltage source in series with a resistance. So by definition, we're going to have a voltage source, which we're going to call VTH, in series with a resistance, which we're gonna call RTH. And then I'm gonna basically draw the Thevenin equivalent circuit as AB. So I'm still gonna have to add this part here later on, but I'm gonna have A and I'm gonna have B, plus minus. Now, RTH, so R Thevenin, in this very case, it's gonna be given by R3 plus R1 in parallel with R2. So R3 plus R1 in parallel with R2. So if I plug numbers back into this, well, I know that, well, the voltage is 12 volt, 1 ohm, 2 ohm, 3 ohms, and who knows. So R3 is 3 ohms, so it's 3 plus 1 in parallel with 2. So RTH is 3 plus the product over the sum, so 1 times 2 over 1 plus 2. So RTH is 3 plus 2 times 1 is 2. 2 plus 1 is 3. So RTH is 3, 9 plus 2. So RTH is 9 is 10, 11. So 11 over 3. So RTH is 11 over 3, which is actually 3.66 ohm. Now, we gotta find VTH as well, so the voltage Thevenin, so the voltage supply of Thevenin. So VTH, in this case, will just be VR2. So basically the voltage across here, so across R2. And across the voltage across R2, if you remember, Ohm's first law, it says, well, VIR. I'm always gonna draw this until you get this into your mind. So V is gonna be I times R. So if V is I times R, then VR2 is basically going to be I times R2. So do we have R2? Yeah, we do. It's 2 ohms. Do we have I? No, we don't. So we're gonna find I. In order to find I, basically gonna say, okay, fair enough. In order to find I gonna find, I is actually, if I'm gonna find I, it's gonna be V over R, okay, I, V over R. And I do have V, but I don't have the R total, because this will be R total. So I'm gonna find R total first, so that I can find I, with which I'm gonna find VTH. So R total will be R1 plus R2. So R total will be R1, which is 1, plus R2, which is 2. So R total will be 1 plus, 1 plus 2, which is 3 ohm. So I will be V over R total, as I said before. So Ohm's first law. So V, we have that, is 12 volt, which is here. And R total, we have just found this, is 3 ohm. So I is 12 over 3, which is simple, is 4 amps. Now, VTH, we can find it. We have everything now. Because it will be VR2, which is I times R2. So it will be I times R2, but we know both of them now. So VTH is I, which is 4 times R2, which is 2 ohm. So VTH is essentially 4 times 2, which is 8 volt. Now, the maximum, well, the problem is actually asking us to find the value of R so that the power transfer at AB is maximum. But the maximum transfer of power is actually when R is equal to RTH, which is equal to to 3.666. So I can say that the maximum transfer of power is when R is actually equal to RTH, which is equal to 3.66. So this is looking promising. Now, with all this in mind, we still have the diode here, but this diode, which is an ideal diode, is polarized so that it's going to let the current flow through the circuit. But the current is actually going to flow through the circuit this way, so it's going to let all the current go through the circuit. And since it is an ideal diode, it's not a real diode, so it has no resistance, no internal resistance whatsoever, I can replace this with the short circuit. So let me just pick the blue pen, and draw this circuit. The Thevenin equivalent circuit with also this part included now. So yeah, we're still going to have plus minus VTH in series with the current, current voltage generator in series with resistance. So RTH, and then we're going to have A here. But down here we would have R. And then this diode, I just replace and swap with the short circuit because it's going to let all the current flow through and go through. So I'm just going to replace it with a short circuit. So this is A, this is B, plus, minus. Now, this is the Thevenin equivalent circuit. And we know everything now, but what did the problem ask us? To find the power and then the energy. So we can find the power first and then find the energy. Now, the power, if you recall from the other video, the previous video, and also from the, of course, Ohm's third law, is actually I squared times R. So power is I squared times R, Ohm's third law. Now, we can say the power is R times, I'm just swapping them. What's I? How can we find I from this circuit? Well, I, cover that, is V over R. V over R. So in this case, we're going to have V, which is VTH, V Thevenin, over R. But we have two resistances. So it's going to be V over R, so V over RTH plus R, everything squared. Now, let me just put all the numbers here. So VTH, we found that is 8 volt. 8 volt. RTH is 3.66 ohm. And we said that R is 3.66. Now, we can just say, okay, fair enough. Just gonna replace all the numbers. So R is 3.66. VTH is 8 volt. RTH is 3.66 and R is 3.66. So everything has to be squared. So power is going to be 3.66 times, well, we have 8 times 8, which is 64. Let me just put it here. We have 64 over, well, let me just do 3.66 plus 3.66 is 7.32. There's 7.32, which we have to square. So P is, well, we can do no, you can do 64 times 3.66, which is 234.24. So 234.24 over 7.32 times 7.32 because it's squared, which is 53.58. So 53.58. So power is going to be, well, what's going to be? It's going to be 234.24. Well, no, why am I doing times? It's divided by that. So 234.24 over 53.58, which is 4.37. So 4.37 watts, which is about 4 watts actually. Yeah, but I'm just gonna keep 4 point.